Hey everyone, and welcome. Today, we're going to tackle one of the absolute biggest challenges in the world of tech. How do you take an application from just a handful of users all the way to millions? It's a really cool journey of architectural choices, so let's just dive right in.
So yeah, that's the big question, right? I mean, imagine you build this amazing app, it takes off, and suddenly users are flooding in. How in the world do you stop it from just collapsing under the pressure? Well, the answer is all about evolution, and it starts from a super humble place.
In that first step, it's almost always just one single computer. This is that classic garage startup vibe, where literally everything you need is running in one box. It's simple, it's cheap, and hey, it gets you off the ground.
Yeah, in this initial setup, one server is doing it all. It hosts the web app, it runs the database, it even handles caching, the whole shebang. It's the definition of an all-in-one. And look, for your first few users, it works perfectly fine.
And how it works is actually pretty straightforward. A user types in your domain, then the DNS, which is kind of like the internet's phone book, finds your server's IP address. A request gets sent over, and your server sends back the website. Simple, direct, effective. For now, anyway.
But then success happens. Your user base starts to grow, and as that traffic starts pouring in, that one little server starts to choke. It becomes a bottleneck. This is really the first big growing pain, and it forces you to make a decision about how you're going to handle this new load. So at this point, you've got a choice to make. You can scale up, which basically means you just buy a bigger, beefier server, more CPU, more RAM, or you can scale out by just adding more servers. And while scaling up is definitely simpler, it has a hard ceiling and one really big weakness.
And what is that weakness? It's what we call a single point of failure. It doesn't matter if you have a tiny server or a massive supercomputer. If you only have one and it goes down, poof, your whole service is offline. And that is the very first problem we need to solve.
And that brings us to our very first key component for scaling out, the load balancer. The easiest way to think about this is like a traffic cop for your app. It just stands there and intelligently directs all the incoming requests across a whole group of servers instead of just one.
Okay, so here's how this works. We add a second web server, right? And then we put this load balancer right in front of them. Now, if one of those servers fails, the load balancer is smart enough to just automatically redirect all the traffic to the one that's still healthy. And just like that, boom, we've gotten rid of that single point of failure. Okay, so we've solved the web server problem. But all we've really done is reveal the next bottleneck. See, both of our web servers are still hitting the exact same single database. And if that database goes down, guess what? The whole system is still dead in the water.
The solution here is something called database replication. So what we do is we set up one main database, let's call it the primary, that handles all the writes, things like a new user signing up or someone making a new post. Then we create multiple replica databases that are just exact copies, and they handle all the read requests, which splits up the work.
And doing this gives us 3 huge wins. First, performance gets way better because we're splitting the workload. Second, we get reliability because our data now exists in multiple places. And third, we get high availability. If a replica server fails, the others just pick up the slack. And if the main one goes down, one of the replicas can just step up and take its place. Pretty cool, right?
All right, so our system is reliable now. It can handle more traffic, but as we keep growing, things just start to feel, slow. So this next phase of scaling is all about speed, all about performance, and making sure our users have a really snappy, responsive experience.
And our number one tool for making things faster is the cache. You can think of it like the system's short-term memory. Instead of going all the way to the database every single time for common requests, the web server checks this super fast in-memory storage first. If the data's in the cache, the response is lightning fast.
But, caching isn't some magic silver bullet. It actually brings its own set of problems. Like, you gotta have a policy for when data expires so people don't see old, stale info. You have to worry about keeping the cache and the database in sync. And just like everything else, your cache can't be a single point of failure either.
All right, so to get even faster, we can offload all our static stuff. Images, CSS files, videos, all the stuff that doesn't really change that often. And that is exactly where a CDN, or Content Delivery Network, comes into play. It's basically a global network of servers that acts as a warehouse for your files.
And the way this works is super efficient. So let's say a user in London requests an image. The CDN serves it from a server that's physically close to them, maybe in London or Paris.
That's way faster. And if that server doesn't have the image yet, it only has to go back to your main server once to grab it, cache it, and then serve it to everyone else in that region.
Okay, so with a CDN handling our static files, we are finally ready to think globally. But to really scale our app player efficiently across the whole world, we have to make this one super important architectural change. Our web servers have got to become stateless. So this is a really important distinction. In a stateful world, the server itself remembers you. It knows who you are. The problem is, your next request has to go back to that same exact server. But in a stateless world, the server has no idea who you are. It doesn't store any of your info. This means any server can handle your request, which is way more flexible and way easier to scale.
So how do we do that? Well, we take all that session data, who's logged in, what's in their shopping cart, and we move it off the web servers and put it into some kind of shared data store, like Redis or a NoSQL database. Now, any web server can just look it up when it needs to. This makes our whole web tier incredibly flexible and super easy to scale up or down automatically. Now, to take this even further and make our system even more resilient, we can add something called a message queue. So think about this. A user uploads a huge video. Instead of making the web server process it right then and there, which would be really slow, the web server just drops a little message into a queue that says, hey, process this video. Then a completely separate group of servers can pick up that message and do the heavy lifting later. This completely decouples our system and keeps everything feeling fast for the user.
Wow. Okay, so we've added a lot of pieces to that simple little server we started with, right? We've tackled reliability, we've tackled performance, we've tackled global scale. So let's just take a second and look at the blueprint we've actually built.
All right, these are pretty much the core principles. This is the playbook. You got to keep that web tier stateless for flexibility. Build in redundancy everywhere, at every single layer. Cache everything you can. Use the CDN for your static stuff. Go global with multiple data centers. Decouple your services with message queues. And finally, for massive scale, you scale the database itself by sharding it, which is just a fancy way of saying you split your data across a bunch of different databases. This right here is how you build a system that can handle millions of users.
So, we've built this amazing scalable system. But here's the thing about system design. You're never really done. Scaling is a journey, not a destination. So the real question to leave you with is, what breaks next? What's the next bottleneck that's going to pop up when we try to go from 1 million to 10 million users and beyond? That is the constant and honestly, the really exciting challenge of building for scale.